So you define the layer 4 policy maps. Then in the policy map, you bind one or multiple class maps. For each class map, which means a different type of traffic, you define the firewall action. And then from the firewall point of view, whatever traffic flows through the router and doesn't match any of the configured class maps is going to match the default class map, which has the default action of drop in there. Now, firewall policy rules, what are the actions? So it's a couple of more actions than this ones, but the main and important actions that you can configure in a policy map for each class map, for each traffic, for each type of traffic, you can either say pass as the action, which means you're going to allow traffic in a stateless mode. It behaves like an access list with a permit action. Of course, this is rarely seen, because as you're going to see, the firewall policy is going to be unidirectional. So if you don't inspect the traffic, you just pass it. It means you have to define firewall policies both ways in there. So ideally, in general, we're going to say the inspect actions, which means that traffic matched in that class map, if for that class map you put the inspect action, it means traffic is going to be allowed in stateful mode, which means the router is going to create entries in the firewall state table or session table and track that session back and forth. And of course, the third action is going to be the drop action. So as you're going to see, what this means is that, taking back this example in here, let me quickly put back the zones. This is my router, and whatever is routable in this direction is going to be a member of the inside zone, because this interface is going to be attached to the inside zone. And then whatever traffic is routable in this direction, because I'm going to bind this interface of the router to the DMZ interface, whatever is routable in that direction is going to be a member of the DMZ zone. So now, taking that example, if for example I match in a class map HTTP traffic, and then in the policy map I call in or I bind that class map in there, and I define an action of, let's say, inspect. So it means I want to inspect HTTP traffic. And then of course, then I'm going to apply this firewall policy for the direction of inside to DMZ. So inside to DMZ, that's my firewall policy, which means I'm going to inspect HTTP traffic, and all other traffic is going to be dropping, is going to match on the default class map with an action of drop. So if I tell the inspect action, what's going to happen is the session is being allowed by the firewall to go out inside DMZ. It's going to create an entry in the firewall state table, just like the ESA. And when the return traffic is being received flowing DMZ to inside, because the firewall has an entry in the state table, it is going to allow the traffic to flow backwards in. But if I change the inspect action with a pass action, which means stateless, just allow the packet to flow through, pass, it means that likewise, if traffic flows inside to DMZ, it matches my direction of the firewall policy inside to DMZ. I'm going to pass the traffic. I don't create any entries in the firewall state table, which means as server A is going to reply the return session, it is going to be dropped, because the firewall doesn't see any entries in the state table for that traffic, which means if I want to allow the return traffic, I would have to create also a firewall policy from DMZ to outside. So I'd have to create a class map and match on the return HTTP traffic, return HTTP traffic, return HTTP traffic. Then configure a policy map and call in or bind that class map and take the action of pass. and then define a firewall policy saying that if traffic flows, if that traffic, the return HTTP traffic flows DMZ to inside, pass it, which means allow it. So far we have gone through the steps of defining the zones, then matching on the traffic with layer 4 class maps. Then we bind the class map in a policy map of type layer 4, and we tell the router what action to take for each of those class maps for each type of traffic. And the main actions that a firewall can take is going to be pass, drop, or inspect. But then we have to actually enforce the policy and tell the direction of that firewall policy to the router. And to enforce the policy, we make use of what I call zone pairs. So we're going to pair together, we're going to logically bundle together two zones and define the direction of the firewall policy. It's going to be inside to DMZ, or DMZ to inside, or inside to outside, whatever the direction is. So in the zone pair, we define direction of the firewall policy, because one zone is going to be defined as the source zone, and the other zone is going to be defined as the destination zone. So with the zone pair, we bundle together two zones, and then we specify what is the source zone, what is the destination zone, and then we activate the firewall policy by attaching in the zone pair the policy map which we have configured before. So what this means is that, looking at the, again in there, to the same example which you did before, if this is my router with the inside zone, whatever is routable is going to be the inside zone, and whatever is routable out there is going to be the DMZ zone. So step number 1 was achieved. Define the zones, define zones. The inside and the DMZ zones, define zones. Step number 2, match on traffic. We use the class map of type inspect of layer 4, and we matched on HTTP traffic. Then step number 3, you tell the router what action to take to that traffic. We define a policy map of type layer 4. We bind or attach the class map, and then tell the router, okay, for traffic match of that class map, what action do you want to take? Inspect action, inspect, pass, or drop. And I'm gonna say, let's say inspect, which means allow traffic and also create an entry in the state table to automatically allow the return traffic. And then option number 4, we define the zone pair, which means I'm telling the router for traffic flowing from the inside to the outside, that direction, inside to DMZ, for that direction, control the traffic as the policy map states, as the configured policy map states. Which means with this configuration, of course, step number 5, which we're going to go through next, is going to be to actually assign those interfaces of the router to the proper zones. So once all of those steps have been defined, now what's going to happen, if traffic flowing from the inside to the DMZ, if it's HTTP, is going to be allowed and inspected by the firewall, which means traffic is going to work, the session is going to work, because return traffic is allowed by the firewall because it creates an entry in the state table. Other kind of traffic, like for example FTP or whatever else, is going to be dropped, because I'm going to match on the default class map within the policy map, which has an action of drop. So FTP is not going to work inside to DMZ. And the fact that the firewall policy is unidirectional, it means that if I would want to initiate traffic in the reverse direction from DMZ zone to the inside zone, because I don't have a zone pair or firewall policy for that direction, all traffic initiated from DMZ to inside, it is going to be dropped. So this is what it means that the firewall policy is unidirectional. It is the same thing like on the ASA. If you think about it, if traffic goes high to low on the ASA, it's allowed by default because ASA, of course, the ASA has some built-in security stateful rules in there because it's a dedicated security device. The iOS on the iOS devices, you have to enable the firewall capability because the iOS device is a router or a switch. So its main scope is not to be a security device, but to route packets or switch packets back and forward. So if you want to add security features in there, you have to configure them manually. So that's why the ASA, which is a security device, has some built-in firewall rules while the iOS doesn't. But getting back on the ASA, so on the ASA, as traffic flows high to low, so also the ASA has something which is unidirectional if you think about it. Because remember that on the SA we had this interface to be interface level of 100 security level, this interface in here, and this interface of gig00 is a security level of 0. So on the ESA, as traffic flows from the zone or security level of 0 to the zone with the security level, so on the SA, as traffic flows from the zone with security level of 100 to the zone with a level of 0, it is being allowed by default. And it's inspected, which means return traffic is allowed dynamically by the firewall in. But of course, if traffic flows the other way around from the low security level to the high security level, that is being dropped. So also on the SA, the firewall policies are unidirectional. If you think about it, it's the same, and it makes sense, the same logic. It's just a different, let's say, concept, and of course different configuration, because it's a security device to begin with, and it's a different platform, different code running. So for traffic going low to high, you would have to allow that traffic by an access list, and the ASA by default is going to inspect that traffic as well, because the ASA is a stateful build. It's designed to be a stateful firewall to begin with. And of course, the last step is going to be to bind the interfaces, the physical interfaces, to the zones. You can bind to a zone either the physical interface or logical interface. Like in the case of IPsec VPN tunnels or SSL VPN tunnels, you're going to map the virtual tunnel interface or the GRV tunnel interface or the VT tunnel interface to a specific zone. This is the last step. You bind a physical or logical interface of the router to a user-defined zone. And of course, one interface cannot be a member of multiple zones. Doesn't make sense, because you have divided the network logically into zones. It doesn't make sense to tell the router, like, this interface in here, for example, is a member of both the DMZ zone and the Einstein zone. Doesn't make sense. Because when you bind an interface to a zone, it means that all traffic routable in that direction has to belong to a zone, not to multiple zones. Doesn't make sense. So you cannot assign an interface to multiple zones, and interfaces cannot be assigned to the self zone, because the self zone controls all traffic destined to the router or initiated by the router. So there is no interface that actually, because all interfaces belong to the self zone, all links to the router behind the scenes, they belong to the self zone. So you don't attach an interface, physical or logical, to the self zone. You assign the interfaces to user-defined zones. Now, if interfaces are not assigned to zones, transit traffic is not controlled by the firewall policies. So that's why this is also a requirement. So it doesn't matter if I configure my class map. So I match on the traffic in a class map. Then I configure the firewall action in the policy map. And then I enforce the policy, let's say, with a zone pair direction, let's say inside zone to DMZ zone. This is useless unless I also bind the interfaces matching on that traffic flow to specific zones. So if I have defined that policy, that firewall policy, and I forgot to attach the interfaces to zones, that firewall policy is null. It's not even inspected by the router. The router doesn't care. It's going to do just regular routing back and forth. Now, once an interface has been assigned to a zone, then all unicast IP traffic, not multicast, that's a restriction of zone-based policy firewall, all unicast IP traffic received inbound on that interface, which is assigned to a zone, is going to be controlled by your defined firewall policy, which have a source of the zone that interface is attached to. So zone-based policy firewall cannot control multicast traffic, because multicast traffic is in most cases unidirectional, and second of all, if it would be the bidirectional, traffic goes out multicast and comes back unicast. So how could a router inspect multicast traffic? The ESA firewall doesn't also inspect multicast traffic because that's not supported. Doesn't make sense, because if you want to statefully inspect traffic, as traffic leaves the router, goes in out, the source and destination IPs he's going to enter in the state table have to match on the return traffic. In the case of multicast, it's impossible, because traffic is going to go out destined to a multicast group, and the return traffic, if you have any return traffic, is going to come back in as unicast. So it means that the return traffic cannot match an entry in the state table, which means that's why zone-based policy firewall cannot inspect or control multicast traffic. Which means that multicast traffic is just allowed by the router based on the multicast configuration. You cannot control multicast traffic with the zone-based policy firewall. Now let's see what ends up happening from the traffic control point of view. So traffic between the user-defined zones and the self zone is allowed by default. So of course it can be controlled by defining firewall policies. But what it means is that as soon as you attach interfaces to specific zones, all traffic from those zones to the firewall, to the self zone, and from the self zone to the user-defined zones is allowed by default. And this makes sense. It's a safety mechanism to make sure you don't lose the control plane of the router, because if you lose the control plane and the measurement plane of the router, then nothing works and you lose access to the router completely, and it's going to be a network down situation. So what I'm trying to say is that, looking back at that example, at the router in here, if you attach this interface of the router to the inside zone, and you attach this interface of the router to the outside, to the DMZ zone, and you attach this interface of the router to the, let's say, outside zone, all transit traffic flowing to the router, like going inside DMZ or DMZ outside or outside inside, so all traffic transiting the router, if it doesn't match your firewall policy, is going to be dropped by default, and that makes sense. But all traffic flowing like this way but destined to the router, which means direction is going to be inside to self, or going in this direction from the router, initiated by the router to router 4. The direction is going to be self to inside. By default, this traffic is allowed. You don't have to configure anything at all. And as I stated, it makes sense. It's like it's by design. It's a safety mechanism, because it would be insane to, as you know, as soon as you attach interfaces to a security zone, that all traffic destined to the router or initiated by the router has to be allowed, controlled by your defined firewall policies. So because that would mean that once you have attached, if that was the case, once you would have attached interfaces to zones, it means that if you forgot to define firewall policy, if you forgot to define firewall policies to the self zone and from the self zone, all traffic would be dropped. And of course, that means that there's going to be a network down problem, because if OSPF or IGP or BGP is down, nothing works. And because routing doesn't work, also you cannot manage the router to fix up the configuration, because you cannot reach the router. So for that reason, traffic to the self zone or from the self zone is allowed by default. But of course, you can configure policies to actually restrict that to protect the router's control plane and management plane if you so choose to, which of course is recommended. Now, intra-zone traffic within one user-defined zone, likewise, it is allowed by default. But of course, you can change that and control which traffic can flow between interfaces of the same zone. But again, this makes sense, because if you take that example as we had before, like this was my router, and both this interface and this interface are attached to the same zone, which is DMZ, it means that all traffic routable in those directions, from my point of view, are having like the same security level, because all traffic, all destinations routable in those directions are members of the DMZ zone. So because is the same security zone named DMZ, it makes sense that by default all traffic flowing back and forward between those two interfaces is going to be allowed by the router. Because if it's the same zone, it means I trust that it's not interzone traffic, it's intra-zone traffic, which means because you define the security zones based on, what is the trusted network, what is the untrusted network, what is the DMZ network, and you want to control traffic between untrusted and trusted with a firewall, between trusted and untrusted, between DMZ and untrusted, and so on. But it makes sense that if you told the router that that out on multiple interfaces is the same zone, it means it's the same security level, it means it is the same trusted networks back and forward, which means it makes sense that by default traffic flowing between interfaces connected to the same zone, it is allowed by default by the firewall. But of course, you can restrict that and control which traffic can flow intra-zone, between which traffic can be routed, and how can it be inspected and allowed by the firewall if it's intra-zone. But by default, all traffic intra-zone is allowed, and that makes sense. And of course, finally, inter-zone traffic, so traffic flowing between different zones, it is dropped by default, because if you don't configure any firewall policies like between zones, traffic is dropped by default, and it makes sense because this is the scope of actually building the zone-based policy firewall. You segment your network into security zones, and then you want to control which traffic can flow between zones and how can it flow between zones. So it makes sense that all interzone traffic is dropped by default unless you manually configure firewall policies for interzone traffic. And of course, traffic between a zone assigned interface and a no zone assigned interface is dropped because this is invalid design, and you cannot fix that up. So like for example, let's say that the previous example, which we had these two interfaces which were members of the same security zone named DMZ, which means all traffic back and forward routed by the router between those interfaces is going to be allowed by default. But if this interface of the router is not assigned to any zone, so it's just a regular router interface, all traffic flowing in this direction, doesn't matter both ways, or traffic flowing in this direction, it is going to be dropped by default, and you cannot fix that up unless you attach also that interface to a zone, and then you define firewall policies like interzone firewall policies. So this is an invalid design, Of course, in some cases it is a valid design, but in most cases it's invalid. Doesn't make sense to have the setup to have a router with some interfaces connected attached to zones and other interfaces not attached to zones. In some designs it makes sense, it's another discussion, but in most cases you're not going to be doing this. But at least you have to be aware of the fact that if traffic flowing between a known zone interface and a zone design interface is dropped, and you cannot fix that up. The only way to fix it is to assign both the ingress and the egress interfaces of the packet flow to the same zone or to different zones, and then configure firewall policies telling the router what to do with that traffic back and forth.